Hello everyone, I'm Enoch Yu. I am one of the board member in HMV, and today I would like to solve three very fun and interesting problems with you. So I hope you enjoy. And I think most of you guys will know, but I'm going to give you around 5 to 10 minutes to try each problem, and I'm going to solve it. And please note that this problem solving section is going to be recorded and it's going to be uploaded in a YouTube channel so that if you want, you can go and check there. Okay. So I hope you enjoy today. And should we start with our first problem? I think I can give you around 6 minutes for this problem. Since there are new people coming, if you solve this problem, I think you can just message me. I personally think there are two great ways of solving this problem. So I received the answer from three participants. Okay, so for the first problem, I think many of you got the correct answer. And so I think the first thing that we can do is think of Vieta. And although not necessary, let's just say that A is equal to the length of the original rectangle of the rectangle, and let B the width of original rectangle. Of course, you can use H, L, and W, but just to follow the convention, let's say that C is the height of the original rectangle. Then we know that A plus 2, we know that A plus 2 is the length of the new rectangle. And we know that B plus 2 is a width of the new rectangle that is given by the problem. And similarly, we can say that C is equal to the height. Now we need to find the volume of the new rectangle. And using the volume formula for the rectangles, I mean the rectangular prisms, we know that it is base times or length times width times height. So we know that the volume is A plus 2 times B plus 2 times C plus 2. And let's say that this polynomial is P of X for convenience. And it is also given that A, B, and C, they are the roots of polynomial. So when we substitute A and B and C into P of X, then we should get 0. So just to rewrite it, when we let it equal to 0, then when we substitute A and B and C, A, B, or C, then we should get 0. And using Vieta's formula, we know that A plus B plus C is equal to negative B over A. So this is equal to 39 over 10. And we know that AB plus BC plus CA is equal to just C over A, which is 29 over 10. And we know that the multiples of all roots is equal to negative um, D over A, which is 6 over 10. Now, let's expand this. There's actually a very great trick when expanding this. So I will just let you know what happens when we expand this. This is what we should get when we expand it, but um, if you're not quite aware of this trick, you can just do it manually. So what you can do is you can expand, you can expand the first two blocks. So this one and this one and this one and this one. So you get AB plus 2A plus 2B plus 4 times C plus 2. When we further expand it, we get ABC plus 2 times AB plus BC plus CA plus 4 times A plus B plus C, and then plus 8. Oh, is everything okay until here? If you have any question, please let me know. Now, because we know the values of A plus B plus C and AB plus BC plus CA and also ABC, we can just substitute it. So we get 6 over 10 plus 2 times AB plus BC plus CA, it is equal to 29 over 10. So times 29 over 10 plus 4 times A plus B plus C, which is 39 over 10, plus 8. So let's calculate this. We get 6 plus 2 times 29 is equal to 58, plus 4 times 39 is 160 minus 4, which is 156, I guess. And plus, oh, can add 8 here. So when we add this, we get 64. When we add this, we get 220. So we get 22 plus 8, which is equal to 30. This should be the volume of the new box. However, I don't really like the method of like this method. I think the problem maker wanted us to use Vieta here, but while trying this problem on my own, I was thinking, what happens when we graph P of x? So let's just use the same variable here. I don't want to change the variables. And we know that, first of all, we know that, oh wait, before doing that, does anyone have question for the first method? I will take that as no. Then I'll resume the second method. So here we know that P of A is equal to 0, P of B is equal to 0, and P of C is equal to 0. And when we just graph this, we can get something like this, where this is P of X. And without loss of generality, we can say that A is less than B, that is less than C. We can say this because if it's the other case, then we're just rotating the rectangle or prism. Did everyone understand that part? Like we can assume that A is less than B and B is less than C, because if we get this, then it's just the same case. The rectangular prism, it doesn't change, but it just rotates. So we can write it like this. Now, there's one thing that I actually wanted to do, and the one thing that I wanted to do is I want to shift this graph. So I'm going to shift this right 2 units. So here it should be A plus 2, it should be B plus 2, and it should be C plus 2. And when we shift it right, we should get P to the power P of X minus 2. Did everyone understand this part? Or you can just speak if you have any questions from here. Okay, then we can assume that because we need to find the value of A plus 2 times B plus 2 times C plus 2, we know that that's just the roots of P of X minus 2, right? A plus 2, B plus 2, and C plus 2, they're just the roots of P minus 2. Then now what we can do is, let's say we have an equation like this, and we want to find the multiples of the roots. So this is what we want to find, and our P of X was this. So I will rewrite it here. So we have 10 to the power of 10x cubed minus 39x squared plus 29x minus 6 equals 0. That's our original p of x. Now we want to find p of x minus 2. So when we substitute x minus 2 into the x, then we get 10 x minus 2 cubed minus 39 x minus 2 squared plus 29 x minus 2 minus 6 equals 0. And we know that the multiples of the roots, which is a plus 2 and b plus 2 and c plus 2, is just 10, the constants over 10 using the VTest formula. So the reason why it is 10 is because the leading coefficient of p of x minus 2 should be 10. There's no other terms greater that has greater degree than x cubed. So since the leading coefficient is 10, we put 10 in the denominator. And we only need to calculate the constant for this function. So we get 10 times negative 2. Oh, and I forgot the minus. Sorry, this Vieta's formula. We get minus 39 times negative 2 squared minus 29 times 2 minus 6. And when we calculate this, I did calculate it and we should get 30. This is the second method that I came with using graphing. And also, the reason why I did this is to minimize the use of theta because I don't really like calculating. Is there any question for the first and the second method? Then let's move on to the second problem. Please tell me if I am going too fast or too slow. I would love to hear it from you. So this is the second problem that we're going to do today. And I think the second problem is a little bit more trickier than compared to the first one. So I'll give you another 6 minutes to try this problem. Oh, hi, we just finished problem number one. So we have around 3 more minutes to solve problem two. I think you can really try this problem. Oh, so if anyone is confused with the question, with the problem, a unique polynomial of minimal degree means there will be multiple polynomials that satisfies those five conditions. However, you want to find one polynomial from all those polynomials that has the minimum degree, and degree is like the exponent of the polynomial. Only one person solved this problem, so I think I can give you 2 more minutes. Oh, okay. Does anybody need more time to solve this problem? If
Wait,
yes,
can you give us, can you give me like 1 more minute?
oh, okay. Oh, okay. So I think the key to this problem is understanding what the problem wants, what the problem maker wants. So let's look at the five conditions first. So we know that if one is a root of p of x minus one, it means when we substitute one to this whole polynomial, then we should get zero. So that means p of 1 minus 1 equals 0. So the first thing that we know is that p of 1 is equal to 1. And we can do the same thing for the second one. So p of 2 minus 2 equals 0. In other words, we have p of 0 equals 0. And if 3 is a root of p of 3x, then we can know that this is equal to 0, which means p of 9 is equal to 0. And if 4 is a root of 4p of x, then we know that this should be 0. And it just means that, oh, sorry, this should be 4. So this just means that p of 4 is equal to 0. Yes, and now let's try to write this polynomial. So what we can do here is, because we know these three conditions, so we know that 0, 9, and 4, they're roots of the polynomial p of x. So we can simply write p of x like this, um, x times x minus 9 times x minus 4. And yes, we know there can be more. We just don't know it right now. And the reason why I didn't put like any constant in front of here is because we know that p of 1 has a leading coefficient of 1. So that means we don't have to put anything. It's not necessary to put yes. So now let's read the next sentence. We have the root that is not an integer can be written as m over n. So we know that p of x has another root that is not an integer. So p of x has a non-integer root, and let's just write it as, let's just say that this root is equal to a. So p of a could be written like this. And of course, we can write more. However, I don't think it is necessary because the problem says p of x is a unique polynomial of minimum degree. So if we actually multiply more blocks, then the degree or the exponent of the p of x, it will keep increase. So we should actually stop here. And now let's see which condition that we didn't use yet. We did use these three conditions. We did use the first condition, and we did use um, this sentence and the last sentence. The only condition that we didn't use is this one, the second condition. So we know that p of 1 is equal to 1, as we restated. So we get p of 1 equals 1 times 1 minus 9 times 1 minus 4 times 1 minus a, and this should be equal to 1. So when we calculate it, we get 1 times negative 8 times negative 3 times 1 minus a is equal to 1. Then we have 24 minus 24a is equal to 1. So we have a equals 23 over 24. And we also know that 23 and 24, they do not share a common factor. So we know that they are relatively prime to each other. So we know that m over n is equal to 24 over 23. And these are just equal to each other. So we get 23 plus 24 is equal to 47. Oh, do you have any question to this solution or this problem? If no, then let's move on to our last problem for today. I think problem number three is, I would say it's quite dirty. It's not like really clean problem, so we should write lots of things. So I think I can give you around 5 to 7 minutes for this problem. Mm. I think two people solved and got the correct answer for this problem. Does anyone need more time? I think I can give you extra minutes.
Can you give 2 more minutes?
Oh, yes, sure. Okay, so for this problem, I think it is really important to keep track of the information that we know. So for certain real numbers a, b, and c, the polynomial g of x has three distinct roots, and each root of g of x is also a root of the polynomial f of x. So let's just say that the three distinct roots of g of x are sub 1, r sub 2, r sub 2, and r sub 3. And we know that r sub 1, r sub 2, and r sub 3 are the roots of f of x too. So let's say that the additional root is r sub 4. And now, using Vieta, we know that r sub 1 plus r sub 2 plus r sub 3 equals negative a over b. I mean negative b over a, which is just negative a. That's our first equation. And the second equation that we can get from g of x is r sub 1, or r sub 1 times r sub 2 plus r sub 2 times r sub 3 plus r sub 3 times r sub 1. And that should be equal to just 1. And that's the second equation that we can get from from g of x. And the last equation that we can get is r sub 1 times r sub 2 times r sub 3, which is equal to negative 10. using beta. That's the third equation. Now, let's look carefully at f of x to see if we can get any additional information. So we know that r sub 1 plus r sub 2 plus r sub 3 plus r sub 4 is equal to -1. And let's say that this is our fourth equation. And we know that r sub 1 times r sub 2 plus r sub 1 times r sub 3 plus r sub 1 times r sub 4 plus r sub 2, 3. And I think we should get 6, I believe. And this is equal to b. That's the fifth equation. And just to double check if we counted every cases, we can just do 6 choose 2. And the reason is because, oh, wait, sorry, 4 choose 2. And the reason is because we have 4 terms or 4 roots, r sub 1, r sub 2, r sub 3, and r sub 4. And we're going to choose 2 of them randomly and make combinations. So when we solve it, we get 6. So we should get 6 terms. We have 1, 2, 3, 4, 5, 6. So yes, we counted everything. And the next information that we can get is r sub 1, r sub 2, r sub 3 plus r sub 1, r sub 2, r sub 4 plus r sub 1, r sub 3, r sub 4. And then the last one, r sub 2, I believe this should be correct. And let's just double check if we count everything. 4C3 is equal to 4 because we're going to choose 3 out of 4 roots. So we should have 4 terms, and yes, we counted everything. And the last information that we can get is r sub 1, r sub 2, r sub 3 times r sub 4, which is equal to just C. And that's our seventh equation. Now looking at this, I think we can try and do something from here. Notice that when we look at our first and fourth equation, we can see that both of the equations have r sub 1, r sub 2, and r sub 3. So let's just substitute it. So let's say that this is equal to -a. So -a plus r sub 4 is equal to -1. That's the first equation that we get with first and fourth equation. And let's try and use why don't we try the second one and the fifth one? So the second equation and the fifth equation. The reason why I did that is because even though we have r sub 4, I think we might be able to group them because when we group the terms with r sub 4, then the remaining terms will be in terms of r sub 1, r sub 2, and r sub 3. And we have all of those information from our first three equations. So we have r sub 1, r sub 2 right here. And we need to have r sub 2 and r sub 3. We have it right here. And r sub 3, r sub 1, I believe it is here. So using the second and the fifth equation, we know that 1 plus r sub 1, r sub 4. I will just factorize it like right away. So we have this term right here. So it's r sub 1 plus we have this term. So it's r sub 2. And we have this term, so we have r sub 3. And that should be equal to b. And we also know that r sub 1 plus r sub 2 plus r sub 3, it is equal to -a. So 1 minus a times r sub 4 equals b. And like which one should we try? I think we can try the third one and the sixth one. So using these two equations, we have -10 from here. And then I think we can just group them. So r sub 4 times r sub 1, r sub 2 plus r sub 2, r sub 3 plus r sub 2, r sub 3, and we have r sub 1 and r sub 3. Yes. This one is equal to -100. And we also know that r sub 1 plus r sub 2 plus r sub 1 r sub 2 plus r sub 2 r sub 3 and r sub 3 r sub 1 is equal to 1. So this whole thing just cancels. It's equal to 1. So we know this. Oh, great. We can find the value of r sub 4. We know that r sub 4 is equal to negative 90. And using this information, I think we can also find the value of a. So we know that r sub 4, negative a, so negative a minus 90 is equal to negative 1. Therefore, a is equal to negative 89. Does everyone agree until here? Or do you have any question? Okay, then I need to calculate b, but it looks quite, yes, I need to calculate b, yes. But let's try and use the third and the seventh equation. I think we might have more simple calculation. So we know that this thing is equal to negative 10. So this whole thing is equal to negative 10. So negative 10 times r sub 4 was negative 90 is equal to c. Therefore, we know that c is equal to 900. So we know that a is equal to negative 89, c is equal to 900, and r sub 4 is equal to negative 90. And we also know the value of b. b is equal to something if we calculate it. But let's see if we really have to calculate this, because I think it's quite messy, or maybe it might not be. And we need to find the value of f of 1. F of 1, yes, we do need to calculate for b. So let's quickly do it. So a is negative 89. So, it's simple. So we get 810 minus 9 equals, so this, I think this is what we get for b. I believe b is equal to negative 8009. Is this correct? Did I make mistake? Is this correct? Did everyone get this value? I hope
Yes.
oh, thank you. I hope this is correct. And the f of 1, we can see that f of 1 is equal to 1 plus 1 plus b plus 100 plus c. And we know that 2 plus, what was b? Negative 8009 plus 100 plus c. I think c was 900. So our final calculation will lead to negative, we subtract 1000. So we get negative 700, I mean 7000, and 7. This is the value of f of 1. So our answer is negative 7007. Did everyone understand this problem, or do you have any questions based on this problem? If not, then I think this is all I prepared for today, the first three problems. Thank you so much for joining. And please note that I'm going to be uploading this recording file into a YouTube channel. And I will also share the video with everyone, so that if you want to check any parts of this recording, you guys can go ahead and check it. Then thank you so much for joining. Thank you.
Thank you.
Thank you.
Thank you.
Thank you. Thank you.
Bye.